Welcome and thank you for being here. In today's webinar, we're going to see a real-life use case of how the Monash University Systems and Analytics team has taken an innovative approach to understanding return on investment in university research. Before I pass you off to our speakers, a few practical notes. First, you can drop your questions into the Q&A panel at any time. We'll save some time at the end to answer them. If we don't have time, we can answer by email afterwards also. Second, you'll see some additional resources in the handouts panel. Feel free to check those out during the presentation. And finally, this webinar is being recorded, so we'll share the recording with you in the next couple of days in case you'd like to rewatch any part of it or share it. And now I'm happy to pass you off to our speakers, Mahyar Nasabi, Philippe Gabert, and Jean Vieux.
My name is Jean Vieux. I'm one of the co-founders of Linkers, and I'm very pleased to meet you for today's webinar. We will be talking about Graph meets Gen AI, building a university-wide research intelligence platform. So let's get started. And for today's webinar, I'm very excited to welcome both Mahyar and Philippe. I will let you guys introduce yourselves.
Since I'm the next on the list, my name is Mahyar Nasabi. I'm a program manager for systems and analytics at Monash University. My background, my specialty at university is research infrastructure and more broader in research services. So it goes, as my title says, systems and data coming out of systems and analytics of those data.
Hi, my name is Philippe Gabert. I'm a senior solutions architect working in the higher education sector at Amazon Web Services. I'm based in Sydney. I have been with AWS for 4 years now and working with customers, especially around higher education and research.
Before we dive into the meat of today's topic, just a quick word about Linkers. The company was founded in 2013. We are a team of 50 plus employees, and on a daily basis, we support more than 10,000 investigators throughout the world who are all trying to make sense of complex connected data. And we do that from offices in France and in the US.
All right, so a bit of introduction about Monash University. So without going into too much details, but to just give you a context around how big is corporation as large as Monash or university comparable size with Monash University, we have, obviously we're located in Australia. We have 8 campuses across 4 countries. 2 campuses with our partners, a partnership with India and China, 100 plus universities partner universities that we work with. Most importantly, we have 95,000 students and 20,000 staff and 500,000 alumni. So why these numbers are important? All I wanted to the takeaway from this slide is this is quite a large corporation, and we're going to discuss about the data coming out of such a corporation and what we're going to do with it in next couple of slides. Yep.
All right, so very quickly about AWS. So AWS is Amazon Web Services. This is the cloud branch from Amazon. It was created in 2006, so more than 19 years ago, from a spin-off from Amazon.com. So we realized that we knew how to handle infrastructure and that we wanted to offer that service for customers. So in 2006, we started that business. We are across the globe, so in 39 regions. For multiple reasons, mainly for performances and for data sovereignty. It is very important for our customers to enforce that the data that they put on AWS stays where they want it to be saved. So for that project, for example, we wanted to make sure that everything remained in Australia. I won't go too much in details about any other thing except the innovation and the number of services we have. We have more than 250 services that range from compute, storage, databases, to the latest and greatest in latest technology like generative AI. A bit more than just the services, the innovation is really at the core of AWS. And we want to partner with customers to build innovative project. And this is the perfect example. The wrap-up of the project that we are going to walk you through today is that example, is a perfect example where we start from a business problem from our customers and we apply technology to solve those business problems. So this is really something at the core of AWS, which I think is really important.
So here's a quick rundown through today's agenda. First, we'll talk a little bit about the RAPA project. Then we will show a bit of a demonstration of the RAPA intelligence platform. Then we'll talk about the technical overview, then go into a conclusion, and hopefully we'll have time some Q&A at the end of the webinar.
Okay, so RAPA. So basically, what it is AI-powered system for research, intelligence, and insight. So let's go to the next step. I will give you next slide, please. So I'm going to give you a quick overview of the landscape. So previously we said, okay, this is a corporation as big as university, Monash University, but in terms of numbers, what we're dealing with in terms of landscape of research data or research intelligence, we have 112,000 researchers, internal and external. So basically 20,000 or 15,000 at any point of time. We have researchers at university and plus all the collaborations that we have with other universities. 54,000 publications. So bear in mind that this is the data between 2018 2023, basically over 5 years. The research awards, which basically we can consider the income for university in terms of research, the money went in for us to do the research. We are talking about $7.6 billion. And the investment that university put into the research infrastructure, our research capabilities in terms of our equipment and scientific services that we provide to our scientists, researchers, and industry, there are $100 million over 5 years, around $20 million a year. So that's at glance how much, like the numbers of across the landscape. All right. So if I want to summarize the current workflow, either government or university invest in our facilities or our researchers. So on the left-hand side, start from investors and government. You see the arrow going toward either our facilities, which is like equipments basically, and services, or researchers through research grants. And then researchers leverage, at this point, leverage our facilities to publish something. So researchers leverage our facilities, and also researchers publish research publications. Okay, and then research publication in turn basically is our currency, is how we go and get more revenue, patent, startup, or more grants. So then you can see the arrow going from all the way from revenue toward the right all the way back to government and say, okay, this is what we have, please give us more money. On the right hand side top, you see the guy research performance team. Basically their job is to collect this insight. So basically we have a team of people on a daily basis, on a weekly basis, looking to how have we done in terms of research output, how have we published, What have we published? Can we somehow infer some sort of usage of our facilities, our research capabilities in these research publications? So their job is collect the publications and also say which of our investment, how did we help these specific publications? So that is where we talk about research performance team. And then at the very top of this graph, this diagram, you will see senior leadership. So basically, at university, like any other big corporation, so their job is to look into, basically allocate investment to our research capabilities, who gets what, why. Also, go back to government and investors and justify, say, we have done, and so by monitoring our outputs, go back to them and say, we have done these great things. Great things at university means research publications, output, but really it translates into social impact. What have we done for the society, right? So basically, the narrative, the final narrative that the senior leadership should make, is here's the investment went in, and 5 years later, here's the social impact that the university created. So that's an explanation of this diagram, in as brief as we can get. All right, so I'm gonna soon hand over to Philip, but the way that we're gonna demonstrate today for you to what Rapper does, basically we thought the best way is who's the audience, right? Like who's gonna benefit from Rapper and what do they get out of it? So if you divide them in three sort of cohort of users and audience. So we have industry and students that can use a Rapper for discovery. We have Rocks team, we call them Rocks, but really what they do is research, output, collection services. Their job is to go out and see what have we published and link that publication, that research output, to entities within universities. When I say entities, it could be researchers, it could be research capabilities, equipment, or anything like that. And also the senior management can benefit from Rapper by creating these narratives that I just talked about. So I'm going to hand over to Philip. Philip going to go through each of these demo and see how Rapper would help us in there. So basically the problem, so if we want to state problem statement, the first statement is unclear return on investment. Government, university, put the investment in. We are missing the linkage between our research investment, research income, which are awards, and research output. We have good understanding of each of these data, but they are sitting in silo without an overview or layer of intelligence across these data sets. Second problem is fragmented discovery and slow collaboration and innovation, which result in slow collaboration and innovation, which means basically for industry or our own researchers within our institution is not easy to find things. We know we have the best of each technology ever existed, but they are buried in layers and layers of information, and it's not even easy for us within the institution to find things, which slows down the collaboration. And then missing strategic insight, again, from senior management, from government, from policymaker point of view, everything is manual. So if you want to report on, start from the investment, go all the way investment or income, research income, all the way to social impact, how can we make that narrative? At the moment is hours, days, weeks, months of someone's time to go and pick pieces of information and stitch them together. So these are the three basically statements that we are trying to solve. Right. Over
Thank
to
you,
Philippe.
Mahyar. Yep. So let's go in the demonstration. So we will use those three type of personas for each of the use cases, and I will walk you through the benefit of the wrapper. So the first type of users are the students in the industry. You are a student in the university, you are doing a PhD in a particular topic. What you want is being able to find people to help you on your specific domain of research, but also find what publications have been made already and what equipment you can leverage for your research. The wrapper is going to help you with that, with the first thing, which is basically just a chatbot. That chatbot, I can communicate in natural language and ask questions. Here, I want to find an expert in structural biology. What the wrapper is going to do is look at the list of researchers, the list of equipment, the list of research paper, and then provide you an answer based on that. In that particular example, we see that James Wistock is the expert in structural biology in Monash University. Of course, we keep a reference of everything we provide, so we make sure that the information we push to the users is accurate and is basically verified. Then I can ask more questions. Has James worked on perforin inhibitors? So I want more information about these researchers. I want to make sure that he can help me with my research topic because he knows that particular topic. Then I can shift towards what equipment can help me. What equipment can I use in the university for that research? In particular here, I can see that that particular cryo-EM microscope is available for me to use. So tell me more about that. Tell me more about that cryo-EM. And so here it will tell me that equipment and all of the technical specification for that particular equipment is available in Monash University. So I can use that as a student for my field of research. So we've seen that with just a few questions, using natural language, I was able to query the wrapper, query that graph database that has all the links between entities and get an answer. I know who to reach out to, I know what equipment is available, and I can also make sure that the researchers that I've found is an expert in the field of my research. So here we were able to find this, to answer the questions based on all of the data sets from Monash University. The second part of the demo is about the ROCS team, or the research performance team. So as Mahyar was explaining, those people read very complicated technical document, very complicated research paper to find the equipment that has been used. So they read many different pages of cutting edge technology content or research content, and they try to map this to the equipment available in the uni, which is extremely complicated. To prove my point, I will just give you a few seconds to read that. This is an actual research paper title that was released by the university, by Monash University. So it's an actual paper. You can actually open up the QR code or look at that link. I'm not even going to try to read that. But essentially, this is what those research performance team have to deal with on a daily basis. They have to read that, they have to understand that, and then they have to infer the equipment that has been used. And this is only the title. It's not even the content of the file. So the content of the file is even harder to understand. So the first thing we've done for them is essentially helping them understand the content. So I'm in the wrapper here, and I'm going to search for the document I've just shown you. So the genomic dissection of endemic Kappa venom. What we've done with generative AI is basically have a simple term analysis. basically please break down the title and explain me what this is all about, because just to give me a high level understanding of what we're talking about. Here, in simple terms, that research is about how the bacteria became more resistant to a very powerful type of antibiotic called the carbapenem antibiotics. In just a few seconds, I can understand what the document is all about. I can start thinking about what equipment could have been used for that. I know what that research paper is all about. So I'm not left in the blind. I can already start thinking about what that document is about. The second use case for this research performance team is actually the core of the wrapper. Remember, they have to look at that research paper and find the equipment that has been used. What we do here is essentially we do that for them. So we have a generative AI model that will read that publication. So read the text, read the images, read the graphs, etc. Extract the equipment that we think has been used to write that publication, and then cross-reference this. Like we found 15 possible equipment here. Then we cross-reference that with the internal database of equipment in Monash. So Monash has the list of equipments that they have. We cross-reference that with the equipment. So essentially for very low value equipment, such as, like, it's not really low value, but a wrench, hood, or things that are very common, we ignore them, but we only focus on the very expensive piece of equipment, the things that are a significant investment for the university. Once we do that, we display to the user the facilities and the equipment. So the equipment are the physical equipment to do the research, and they belong to a certain facility. From here, it's very easy to pick the one that are correct and the one that should not even be in that list. So you don't have to look at the whole document. We can do the work of identifying those documents. And if you start to think about it, we have documents, we've got researchers, we've got facilities, we've got equipment. All of this data is interconnected. And this is the perfect example for a graph database. Hence the use of Neptune for AWS and Linkurious for the visualization. All right, so we've seen that the RAPA is helping that research performance team understanding the research paper, the research topic that they are going through, doing that deep analysis of the PDF or of the publications to find the equipment, infer the potential use of the equipment, but we still have that human in the loop process. We still want the people to verify that what the generative AI came up with. So we still have that team to validate what the model has found out. The last part of the demonstration is about the senior management. So the Pro-Vice Chancellor for Research Infrastructure, the DVCR, the deans of the university. What they want is that aggregated view, that complete analytics of the whole data set. I want to know what topics we are strong in. I want to know what equipment we have, what equipment has a strong ROI. And I want to be able to take decisions based on data. I don't want to take any decisions for the future based on my gut feel. I really need to have that data-backed decisions. And the RAPA can also help with that. But the typical use case would be the following. So you've got a research equipment manufacturer. So we call that Acme here, but it could be like manufacturer of microscope, of cryo-EM, of literally anything, those very expensive pieces of equipment. They will contact the university and they will say, hey, Hi, Monash. We'd like to partner with you on building the next generation of UHPLC. Are you guys in? Unless the Pro-Vice Chancellor is extremely good in knowing all of the technology, the very first question he may have is, okay, what is UHPLC? And do we do anything with UHPLC? And so that's again what something that the wrapper can help with. So I'm going to show you what the PDCR could do. So first thing, ask about, okay, what's UHPLC? So first, we got an answer. UHPLC stands for Ultra High Performance Liquid Chromatography. It's an advanced form of high performance liquid chromatography. Okay, so I start to get some ideas about what it is all about. Then, because everything is interconnected, we can give more information about, okay, do we have such an equipment in the uni? And here, yes, we do. In HMS Trust Analytical Laboratory, we do have several UHPLC systems. So as a senior management, I know what UHPLC is, and I know that Monash University has this equipment, and we have some knowledge into it. So the next natural thing to do is go to Linkurious and say, okay, tell me more, tell me anything about UHPLC. And here what we do is we basically show all of the nodes that relates to UHPLC. What does that mean? So first in pink here, we've got HMS Trust Analytical Laboratory. So what the chatbot gives us is what we see here. We have a facility that has some equipment that are UHPLC. The equipment are in red, so LCMS 8060 and all. So those are the UHPLC equipment that are linked to that particular facility. Because it's graph and because I can explore the data, I can also see that that particular equipment, the UHPLC 4, 5, 6, and 7, has been leveraged to write that research paper at the bottom, like analytical validation of etc. So this is in green, a research paper that has leveraged that UHPLC. So I can navigate and open up that publication and see who wrote it. So who was the author of it? In that example, that was Chongqing Jiwi, who wrote that document. He belongs to the Malaysian School of Pharmacy in the university. So really we can navigate from the facility to the equipment, to the research paper, to the people who wrote that research paper. I can then expand on that particular author and see what he has written in the past. So if I double click on this one, it will show me all of the equipment that he has leveraged, and in green, all of the research paper he has worked on. So now going back to the view of the PVCRI, so that's senior management in the university, I was able to understand what we are talking about. I was able to understand what equipment we have in the university and what skills we have related to that technology of that university. Being able to identify what publication we released in that field, so I can clearly say to the manufacturer who contacted me in the first place, yes, we do know what we're talking about. We do have significant investments in your technology. We do have experts that can help you build the next generation of UHPLC. So that's really the purpose of the wrapper for the senior management. Now, from a technical standpoint, so if we look at the architecture diagram, so that's more for the AWS folks in the room, we basically have three main components. The chatbot is built on Streamlit and it runs in a container on Fargate. The whole front end is saved in Amazon S3 using Cloudscape as the design system. And to run Linkurious, we run that onto an Amazon EC2, so just a normal instance. Really, the core of the wrapper resides in two things. On the right-hand side, Bedrock. Bedrock allows us to call the large language model to analyze the PDF and to answers to the users through the chatbot. And Neptune, which is our data store that stores all of the links between equipment, facilities, publications, etc. Now, how did we get the data? So all of the data that we showed you had to go from Monash University systems into Bedrock knowledge base to basically be able to answer to the users, and also into Neptune for the visualization in link areas. What we've done is we got the data from two websites, the Research Capability Finder that has the list of all of the equipment in the uni. And we extracted this and saved that into Neptune for visualization and Bedrock for the knowledge base. The second data set was a much bigger data set. That was the list of all of the publications, all of the researchers, etc. This project is still in the proof of concept / pilot phase. So we wanted to have a significant amount of data while not take everything. We didn't want to get all of the documents that Monash releases. That would have been too big. So we only limited to 15,000 documents for the last 5 years. So we got the data from the Monash website, and again we saved the data into Neptune and Bedrock for the wrapper data store. All right.
All right, perfect. Thanks, Philippe. So what are the key takeaways? So if we go back to very first few slides that I provided the landscape of this research ecosystem, basically we are talking about researchers, massive data set of researchers, research output, publications, and awards, research incomes, all the grants coming in. So these were sitting in silos. What Wrapper does, it brings a layer of intelligence over all these three and sort of link them. So you can see them, and with help of link areas, you can visualize them. Very complex, many nodes and many complex edge between them, you can visualize them. In terms of strategic reporting, again, years ago, if you wanted to do this thing and run a report across these three silo data set, it would have taken months or years to set up such a system to be able to link these data. But the strategic reporting across multiple data set, Wrapper is able to do that. Instant AI powered discovery, basically that natural language. So you can ask a question and discover something, find something which is buried under layers of information using Wrapper. What it ends up doing, it basically empower the collaborations and impact. So basically, as you can find the capabilities, you can do better collaborations. And finally, the tailored insight means doesn't matter which of these personas that Philippe demonstrated. If you're a senior management, if you're a first year PhD student, if you're a research publication collection team, you can tailor the insight, you can tailor the report and get the information out for your purpose. So that is what Wrapper provides. And again, Linkurious is a great help there, because make that complex graph database with millions of nodes and edges queryable. So you can query and say, okay, now tell me this. Tell me all the links to this specific node that I'm interested in. So yeah, having said that, that's the end of the presentation. Thank you. Yeah, cool.
All right, so we have time for a few questions. I see some questions dropped into the Q&A panel. So, all right, we have one about the AI. So what AI model did you use for RAPA?
All right, so we've used Anthropic Claude Sonnet 3.5. So that was when we started that proof of concept. That was the latest and greatest available in Australia. But because we actually leverage Bedrock, like Amazon Bedrock under the hood, and we call the same APIs, we could very easily switch to the latest that are available. So the 4 Sonnet 4, for example, or 4.6, we could use this.
Perfect, thank you. So there's another one. How do you ensure accuracy of information in the chatbot?
That is actually a question that comes very often. So what we do is we have a multi-shot prompted. So again, it was all before agents and things like that. So the approach that we took is multiple prompting, a chain of thoughts approach, where the model is going to respond, and then we are going to check that response and verify it against our data sources. Everything is grounded to the data store that we have. So all of the data that I was explaining, we took from the Monash website. We saved that into knowledge bases that we use as our reference, and we make sure that chain of thoughts was applied. So all of the information that we provided was correct. I think Mahyar, correct me if I'm wrong, but or if you want to give more details. But at some point, you did try to replicate that approach. Do you want to talk through that?
Yeah, so at the time, again, to answer that question, because that's almost the always one of the top questions. We try to replicate RAPA using just directly go to not RAG, not augmented with our knowledge base, and we try to just go directly to like ChatGPT or through API to other LLMs. And the amount of hallucination and the amount of incorrect responses that we were getting was not tolerable. So basically, it was way more than what we had with RAPA. And also, having said that, RAPA, the first version that we had a bit of hallucination in it, and then we basically in next versions, in iteration of RAPA, we try and say, okay, how can we cross-reference with our knowledge base and make sure there is reasonable, grounded answer coming out. Having said that, really the next step would be to systematically measure the exact accuracy. So what is the accuracy? What is the at some point we will do that, and we have to systematically in real time almost monitor such a error or hallucination before we go and we go live as an enterprise product with RAPA.
Okay, super interesting. Thank you. So here's another one. What happens if you have multiple instruments that could have been used for publication, in parentheses, like if the university has multiple MRIs and RAPA identifies an MRI has been used?
Monash Research Office thing is MRI. So that is. So do you want to take that answer? Now I can add a comment, Philippe.
Yeah. So as I said a bit earlier, so we still have a human in the loop, right? So the idea is instead of the Rocks team to read, I don't know, 50-page of document to say, I know that an MRI has been used. And then they need to do some research on what MRI exactly has been used. We basically remove that step of reading the research paper and identifying the MRI. At the end, the ROCS team, the research performance team, still has to say, okay, I know that an MRI has been used. I still need to validate which one. I can then cross-reference that with the utilization application that tracks the utilization of each of those equipment. But essentially, that step of reading everything to say that it was an MRI that has been used is removed. The last mile, if I could call it this way, which is identifying which MRI, is still something that the research performance team has to do.
So my comment on that is by design. So but we intentionally put that human verification in there because we can never remove that human verification. Why? The reason is, imagine some of these publications are in collaboration between multiple universities and sometimes hospitals. Quite often there is duplication of these resources in these various institutions. Imagine we publish a paper with a hospital in China. Whatever MRI that we have at Monash University, identical MRI they have in China in that hospital. And of course, LLM can never say which one was used because they are exact model, exact same setup, which one was used in this publication. And that is the step that the only person, the only group of people can answer that questions are the authors. So basically, there are scenarios that I can imagine that we can never answer the concrete answer to questions of it has been used or not. We always have to go back to the source of truth, which is the group of authors, and say, has this MRI been used or not? And on the top of that, again, another scenario is we have very similar equipment. Both of them are high end, but with slight different configurations. So that is not known to LLM or to almost anyone at university other than the facility managers or the authors themselves. So again, these are the scenarios that we never can rectify, and that's not the purpose of RAPA. The purpose of RAPA is to remove that very long time consuming, and to be honest, no one has that much knowledge to infer usage of all the equipment from all the publications ever published. So that is the purpose of RAPA.
Perfect, thank you. So I see a last question coming in here. Why did you choose to use Link Curious with RAPA?
All right, I will take this one.
You can answer technical.
Yeah. So we started by we saved the data into Neptune. Neptune, when you want to query Neptune or any graph database, you need to learn Gremlin or Cypher, which is kind of complicated. And you don't have that holistic view. You don't have that comprehensive view. So I reached out to some of my colleagues in AWS asking if we had partners for visualization of graph database. And they mentioned Link Curious as the leader in that field. And when I started to use Link Curious, I was actually kind of blown away because it was able to handle thousands and even more of nodes and to really navigate through them all, like just in a few clicks. So for me, that was really the ease of use and the wow effect that it brings. The cherry on the cake for me was all of the customization that you can do, like changing the colors, the icons, etc., because that gives really, again, that wow effect. We've shown that demonstration to multiple universities, to multiple events, even in Amazon, and that graph view that linkage between all of the entities is what brings people on board, what actually interests people. So that's why we choose Link Curious.
Fantastic, thank you. So I think that's all we have time for today. If we haven't had a chance to get to your question, we'll try and answer it via email afterwards. So thank you everyone for joining, and we'll see you at the next webinar.
Thank you.
Perfect.
Thanks, everyone.
Thank you, everyone. So, yeah.